Now we should know that how the insulin secretion is regulated. So the first and the most important point in regulating the insulin is the blood glucose level. Now this blood glucose level has biphasic effect, which means the primary response and the secondary response. So as always, a primary response always has an immediate response and a very faster response. So if the fasting glucose, if a person has a fasting glucose of 80 to 90 milligram per 100 ml, the rate of insulin secretion is normal. But as soon as it shoots up more than 100, more than 200, or between 100 to 200, the insulin secretion gets doubled up. So the primary response or the first phase is immediate release within 1 minute, and it peaks at a 3 to 5 minutes and declines to a basal level. Now this is due to the release from the labile pool. The second phase, or you can say, is the secondary response. So this is a slow, this is not as immediate as the primary response. So it is a slow response. It is maintained and prolonged release after 2 to 3 hours of continued infusion, and this is due to the already stable pool. So when this labile pool is, what do you mean by this labile pool? That is, as soon as the glucose concentration shoots up, what does happen? Whatever at that point of time the insulin is secreted, just at that point of time, that is a labile pool. And the stable pool, that is always a stable concentration is always present in our blood, in our body, a normal concentration of the insulin, from which now the secondary response is happening. So that is why it is also known as biphasic effect. The second regulatory factor is the protein. So whenever there are excess amino acids in the blood, it also stimulates the insulin secretion. The major two the proteins are the arginine and lysine. You can ignore them if you don't want to learn them. Now GIT hormones. All the GI hormones, it causes the anticipatory increase in the blood insulin levels in the. So anticipatory means body always anticipates whatever things. Now the body is anticipating that this person is increasing this much amount of this, the person is having this much amount of glucose now. So all the GI hormones, they are, for example, the gastrin, secretin, and cholecystokinin. It causes the anticipatory increase in the blood glucose, in the blood insulin level, in preparation for the glucose which is to be absorbed from the meal. And also there are some endocrine hormones which also increases the insulin, like for example cortisol, glucagon, and growth hormone. So if I have to just summarize the insulin, what I can see over here is, if the plasma glucose increases, this will stimulate the beta cells of the pancreas, and what will happen, there will be increased insulin. Now this increased insulin will go up to the liver and will cause glycolysis, glycogenesis, and lipogenesis. Lipogenesis means fat production. Now this insulin will go up to the muscles, and what will happen, they all will take up the glucose, so increase glucose transport. And with the help of these two factors, the plasma glucose is now decreased. Okay, so if I go here, increased plasma glucose will cause the increased glycolysis in the liver, and in the muscle it will cause the increased glucose transport, and this will inhibit the alpha cells in the pancreas. Decreased plasma glucose also has a negative feedback loop, as you can see over here. It also has a negative feedback loop on the beta cells of the pancreas. So whenever there is less and less amount of plasma glucose, then the insulin secretion has now stopped. Now coming on to the glucagon. Glucagon is so intense that infusion for 4 hours can cause glycogenolysis, that all the liver stores of the glycogen can become depleted. So it is very, very intense in its action. So this is secreted from the alpha cells in the islet of the pancreas and it causes the glycogenolysis. So as soon as the receptors in the pancreas, they sense the decline in the blood glucose level, for example during the period of fasting or during prolonged exercises, so the alpha cells secrete glucagon, and which causes the glycogenolysis and increases the blood glucose concentration. It also increases the rate of amino acid uptake by the liver cells and henceforth converting them to glucose with the help of a process known as gluconeogenesis. The glucagon increases the transport of the amino acids into the liver cells, which are utilized for the gluconeogenesis, and it stimulates the lipolysis. The breakdown of the lipids yield the free fatty acids. उसकी वजह से fatty acid release हो जाएंगे, which may be oxidized completely to carbon dioxide or incompletely to form ketone body. So these fatty acids, if they are oxidized completely, then they form carbon dioxide, or if they incompletely oxidized, then they form ketone. If I talk about the regulation of the glucagon secretion, blood glucose level, when it decreases below 80 milligram per deciliter of blood, the alpha cells are stimulated and they secrete glucagon. If there is increase in the amino acid, it will stimulate the secretion of glucagon, and henceforth it will cause what? It will convert the amino acids to the glucose. It will convert the amino acids to the glucose. And the other factors are always, in the cases of the exercises, stress, there is always increased glucagon secretion, and the somatostatin, insulin, will cause a decreased glucagon. So if I have to summarize the glucagon synthesis, whenever there is decreased plasma glucose, it will stimulate the alpha cells. It will stimulate the alpha cells, and what will happen? Increased glucagon, and this will go up to the liver. So it will cause the glycogenolysis, gluconeogenesis, and this will cause the so glycogenolysis, gluconeogenesis, and all the two functions will cause the increased plasma glucose level in the blood. So this plasma glucose is used by the brain and the peripheral tissues. Now what happens whenever there is prolonged hypoglycemia? What happens? The liver start to produce ketones in our body, and these ketones are very, very harmful for the brain. So these are some complications in the cases of the prolonged hypoglycemia. So this plasma glucose inhibit the beta cells of the pancreas, and henceforth less amount of insulin is secreted, and the muscles and the adipose tissue do not now they have efficient amount of the glucose. So the insulin, whenever the insulin dips down, so what will happen? The tissues cannot take up the glucose in themselves because of the decreased permeability, as I've already mentioned all the functions of the insulin. So what will happen then? The fatty acids, the lactate, pyruvate, all the amino acids, they will go up to the liver and help in the formation of the glucose and the breakdown of the glycogen. So if I have to summarize the balance between insulin and glucagon, if a person is a fed state means a person had a meal, what will happen? The insulin will dominate. So this will cause a glucose oxidation, glycogen synthesis, fat synthesis, protein synthesis. And when a person is in fasted condition, what will happen? This glucagon will cause glycogenolysis, and it will gluconeogenesis. It will increase gluconeogenesis process and increase also the process of the formations of the ketones, ketogenesis. So if we talk about the glucose homeostasis, now what will happen? As you can see in the middle there is homeostasis. So the stimulus, if there is rising blood glucose level, the high blood glucose level will stimulate the beta cells, the insulin is secreted, body cells take up more glucose, liver will take up and is stored as a glycogen, and then blood glucose level will decline to a set point, and then the homeostasis is achieved. Now what will happen? The stimulus is the declining blood glucose level. As you can see. So what will happen? The alpha cells are stimulated, glucagon is secreted, liver will break down the glycogen, release the glucose into the blood, and this blood glucose level will rises to a set point, and henceforth this homeostasis is achieved. So this homeostasis is achieved by both the roles of the insulin and the glucagon. So with the help of both insulin and glucagon, between the balance between these two hormones, the glucose homeostasis is achieved.